All right, so we're going to cross out this top part because we don't need it. And let's do some vocabulary. Point-slope form is another formula for the equation of a line, which is easily written when you know the slope, or your m, and a point on the line. Right here we have the point-slope formula, and we want to make sure we know all the vocabulary parts. y1 is going to be your y-coordinate. M is your slope, and x1 is your x-coordinate. What we will do is we will plug everything in. All right, so let's practice that. So over here, the first thing we're going to do is we're going to label. We've got 8, 3, which is x1, y1, and then our slope. Let's make sure we practice by writing that formula down. Y minus y1 is equal to our slope, x minus x1. The more we write it, the better it stays in our brains. Now, plugging everything in, we have y minus y1. y1 is a 3, is equal to m, our slope, which is 1/4, parentheses x, minus x1. Our x1 is 8. What I want to point out here is, notice how the y1 is a 3 and it's now a -3, and our x1 is an 8 and now it's a -8. So that's something to start thinking about of what's happening to each of our points. We're going to label again x1, y1, and then our slope. We're going to write our formula. Y minus y1 is equal to m, our slope, x minus x1. Now we're going to plug everything in. That's y minus y1, which is 12, is equal to m, our slope, which is -2, x minus x1, and that's a -6. Now you're going to notice that right here we have 2 negatives in a row, and I want to change that, so I'm going to rewrite this correctly. Y minus 12 is equal to -2, parentheses, x plus 6. That's going to make my life a little bit easier right there. Notice that the 12 is now a -12, and notice that the -6 has become a +6. So that's something to pay attention to again with that point. We want to label x1, y1, and then our slope. We're going to write our point slope formula, which is y minus y1 is equal to m, our slope, parentheses, x minus x1. I want you to think about, what do you think is going to happen to these 2 points when we plug everything in? So that's going to be y minus y1, which is a -11, is equal to m, our slope, which is 5/2, parentheses, x minus x1. x1's a -2, again, those extra parentheses, but we don't want 2 negatives in a row, so that first part's going to be y plus 11 is equal to 5/2, parentheses, x, again, 2 negatives right there, is going to become a +2, and then I can make the note that -11 became a +11, and -2 became a +2, so that's something, again, to think about. Labeling x1, y1, and then our slope. What do you think is going to happen to that point based on the previous 3? Maybe make a note of that, and then let's go over it. So we have y minus y1 is equal to m, our slope, parentheses, x minus x1. I'm now going to plug everything in. Y minus y1, which is 0, is equal to m, our slope, which is 9, and then x minus x1 is a 1. And again, you should have made note, we started out with a +1 and a 0, and now we have minus that 0, and then we have now a -1. So what do you notice in the equations that were affected by the sign of the ordered pair values, positives and negatives? We can say that we notice that the signs of the coordinate point is opposite of how it appears in the equation. So something that I always point out is always pay attention to the sign to the left. So that means that when you are looking at the formula, then you can actually pull those numbers out, paying attention to the sign to the left, and then you know that it's going to be opposite. All right, let's continue. So for each of these equations in the point slope form, list the slope of the line and the point of the line. So above each one, we're going to write y minus y1 is equal to m, our slope, parentheses x minus x1. So I want to point out that m is our slope, so m is -7, but I want to list off to the side y1 and x1. So our y1 right here is a -2, and our x1, which is right here, is a -3. I need these to be opposite. That's important. So since they're both negative, they're going to become positives, and the x is a 3 and the y is a 2. That's why we need to know that those points became opposite. Again, let's label y minus y1 is equal to m, our slope, x minus x1. So then here's our slope. So our m is our slope, which is 9/4. And then let's label our x1, y1. My x1 right here is a -3. And my y1 is a +8. But these need to be opposite. That's important again. So instead of -3, it's a +3. Instead of a +8, it's going to be a -8. Labeling y minus y1 is equal to m, our slope, x minus x1. Our slope again right here, m is a -2/3. And then we're going to label x1, y1. My x1 is right here and it's a +9. My y1 is a +6, but we need them to be opposite because that's what happens to them in the formula. So it becomes a -9, -6. So a graph line has the equation y plus 1 is equal to -8, parentheses x minus 2. Camden and Drew agree that the slope is -8. So if I was to write my y1 minus, if I write y minus y1, y minus y1 is equal to m, parentheses x minus x1, then I do agree that the slope is -8, and both Drew and Camden agree with that. However, Camden thinks that the point is -2, 1, and Drew thinks that the point is 2, -1. So if I write down my x1 and my y1, I can see that x1 is a -2, y1 is a +1, but I need them to be opposite, so that means my point is going to be 2, -1. And that means that Drew would be correct in this case, and that's because when looking at this, the coordinate point will have to be opposite sign of the sign in the equation. So again, noticing how to pull out that point and that it needs to be opposite is very valuable for us. And again, I write it as I see it with the sign to the left, but then I change it to the opposite. So to write an equation in point slope form, given 2 points, first you're going to use your slope formula to find the slope. Then you're going to substitute the slope and the values from one ordered pair into the point slope equation. So we're going to label first. We have x1, y1, x2, y2. Yes, you have a way to do this in Desmos, but we're going to practice the formula. So my slope is y2 minus y1 over x2 minus x1. y2 is 22 minus y1 is 4 over x2, which is 4, minus x1, which is a -2. 22 minus 4 is 18. 4 minus a -2 is a +6. We can simplify by dividing both of those numbers by 6, which gives me 3/1, which is just 3, and that is my slope. So my m, or my slope, is 3, and we find that right there. Now, in each of the following boxes at the right, we're going to substitute in the slope and the given ordered pair. So we're going to label x1, y1. My formula for point slope form is y minus y1 is equal to m, my slope, x minus x1. Now that I plug everything in, y minus y1, y1 is a 4, is equal to m, my slope was 3, parentheses x minus x1, which is that negative 2. Now, here's the big thing that we have to pay attention to. We do have that y minus 4 is equal to 3, parentheses, x, but we have 2 signs in a row, so that's going to be plus 2. Again, that's making both of those points opposite. We now have a negative 4 and a positive 2. From there, we can start solving to turn it into slope-intercept form. So we're going to distribute and multiply. So y minus 4 is 3x plus 6. I then do the inverse operation, and I'm going to add 4 to both sides, but I can only add it to the constant because it does not have an x. That gives me a 0 pair, and I'm left with y equals 3x plus 10. Notice that you have the point slope formula, and then you have slope-intercept formula. All right, again, we're going to label x1, y1, write our formula down. Y minus y1 is equal to m, our slope, x minus x1. We're going to plug everything in, so y minus y1, which is 22. Notice it started out at a 22. It's now a negative 22, is equal to m, our slope, which is 3, parentheses, x minus x1. x1 is a positive 4. Notice it started out as a positive 4. It's now a negative 4. So when I rewrite this, it's y minus 22 is equal to 3, parentheses, x minus 4. So then again, there's our point slope formula, and we can start solving. So we're going to draw a line. We're going to distribute first, and we have y minus 22 is equal to 3 times x is 3x, and 3 times negative 4 is a negative 12. And then I have to move that negative 22 over, so we're going to add 22 to both sides, but it's a constant, so you're only going to add it to the constant. That created a 0 pair. And then y is equal to 3x plus 10. So what you can see here is that regardless of what point that you plugged in, your slope-intercept form is going to be the same. So as you're solving on your own, you're going to notice what's happening there. All right, let's continue. In 11 through 12, you're going to write an equation of the line that passes through the points in point slope form, then rewrite the equation in slope-intercept form. So we want to first label x1, y1, x2, y2. We're going to find our slope. So our slope is y2 minus y1 over x2 minus x1. Plugging those in, we have negative 3 minus a negative 5 over x2, which is 12, minus x1, which is 8. Negative 3 minus a negative 5 is a positive 2 over 12 minus 8. And that's 4, and that simplifies to 1/2. So we know our slope is 1/2, and then we have y minus y1 is equal to m, our slope, parentheses, x minus x1. We're going to plug everything in. I'm going to choose to use this one right here, just because, but it really doesn't matter. Then we have y minus y1, which is a negative 5, is equal to m, our slope, which is 1/2, x minus x1, which is 8. However, we cannot have those 2 signs in a row, so when we rewrite it, it's y plus 5 is equal to 1/2 x minus 8. Now we have to change it to slope-intercept form. So when we do that, we're going to first distribute. So we have y plus 5 is equal to 1/2 x minus 4, because I distributed. Then I have to subtract 5 from both sides, and I have to line that up under the constant, which created a 0 pair. And we're left with y equals 1/2 x minus 9. If you need to do this on a separate sheet of paper, it'll give you more room to write, because this is kind of condensed. Okay, continuing on, we're going to label x1, y1, x2, y2. So our slope is going to be y2, which is 44, minus y1, which is 18, all over x2, which is 6, minus x1, which is 2. 44 minus 18 is 26. 6 minus 2 is 4. We can simplify that down. Not sure where my video stopped, but over here I did my slope formula, which was 44 minus 18 over 6 minus 2. That simplifies to 26 over 4 down to 13 over 2, which is 6.5. You can use either the decimal or the fraction. So then now changing that to point slope formula, y minus y1 is equal to x minus x1. Plugging it in, I'm going to use this formula right here, or this point right here, y minus y1, which is 18. Notice it went from a positive to a negative there. And I forgot part of my formula. Let's fix that. M parentheses x minus x1. All right, so then again, that equals my m, my slope, which we found. We'll use 6.5 in this case. X minus x1, which is 2. Again, we went from a positive 2 to a negative 2, so we leave it like that. So y minus 18 is equal to 6.5 parentheses x minus 2. I didn't need to rewrite it because there's no two signs in a row. Now we're going to draw our line to do inverse, and we're going to distribute. It's a little bit easier to distribute with the decimal. So then we have y minus 18 is equal to 6.5x minus 13. And then we're going to add that 18 to both sides, which is a 0 pair, and we're left with y equals 6.5x plus 5. Again, I apologize for the video pausing in that one and going back over that. I want to make sure that you understood that slope formula and plugging it in. All right, now what happens when we write an equation in the relationship of these tables? What do we do with the tables? Well, in all honesty, on both of these, it really doesn't matter which one you choose to do, but you pick out 2 points. I choose to use this one and this one on this one just because when I look at this, I can see that there's no decimals. And so I am going to go straight to slope intercept form. So we have our slope, which is y2, and again, we've got 0, 8 right here, and we've got 4, negative 7. So y2 is negative 7 minus y1, which is a negative 8, over x2, which is 4 minus x1 is 0. When I solve that, I get 1 over 4 for my slope. And then when I do y equals mx plus b, my y equals my slope, which is 1/4 x plus b. My b is going to be negative 8, and that's because when x equals 0, my y is my b. And that's why on this particular one, it's easier to just go straight into slope intercept form. So that's what's important for you to recognize here, is that there are times when it's easier to do one way versus the other. If you have your y-intercept, so right here, that is your y-intercept. When you have that, it actually makes sense to go straight into y equals mx plus b versus there's no y-intercept shown here. So in this case, what you would want to do is you want to go ahead and pick out your 2 points. And I would pick out this one and this one just because they're the first ones. And that's 5, negative 1, and then 10, negative 16. So when I find my slope here, I do y2 minus y1 over x2 minus x1, and I get negative 15 over 5, which simplifies to a negative 3 for my slope. And then I'm going to pick out one of those 2 points. I'm going to pick out the first one that I did. So that's x1, y1. And this makes more sense to do point slope simply because I don't have that y-intercept listed. So I would do y minus y1, and y1 is a -1, equals m, my slope, which is a -3, parentheses x minus x1, so -5. And so this, I can't leave like that, so it's y plus 1 is equal to -3, parentheses x minus 5. So having that y-intercept is what's going to make this a little bit easier, and paying attention to that. So if you have any questions, please make sure you ask your teacher. Other than that, have a great day.